Today I'm going to walk you through one of the use cases for multi-agent systems where, let's say, in your front-end application, you have your own organization-specific common components that are used organization-wide, and you want to create pages or applications on your React application by just using your own components, right? Generally, the LLMs, if you ask them to create a page by just putting in the screenshot, they'll give you like basic HTML of these buttons, inputs, and whatnot, right? But let's say you have a very complicated React components, right? Maybe grids, tables, or whatnot, and then you want to create pages for your organizations based on your own common component libraries and not something which is available on web. So I have built a multi-agent system for that. So let's suppose that you're working with Figma and Jira on the back end where you can communicate with um, your Figma and Jira with your MCP servers to get specific uh, page, right, in a JSON format of what it actually does, what are the paddings, margins, blah, blah, blah. And this is how it might look like. And then you have your Jira as well, right? User story to create a user dashboard. And this is the name of the page that you want to create uh, for your common component libraries with this particular page. And this is the acceptance criteria. And and the output of that would look something like this, right? So these are your own common component libraries for Avatar, as well as the buttons and whatnot, right? So uh, these are also the events that has been captured. If you look at the Jira ticket, you have this trigger edit, right? And that's captured over here for you to write code in it and whatnot. So that's what we are going to look at. So to begin with, I'm going to look at, so this is the orchestration pipeline in a multi-agent workflow, and I've kept it simple so that we understand what goes on behind the scenes. These agentic workflows are super complicated, especially determining what the scope of the entire application is. But this is for our clear understanding of how things work out. So uh, you have the design agent, right, which is going to pull up this particular Figma and going to parse this and understand what's going on. And uh, this is your story agent, which is going to go and parse this particular JSON and understand what the acceptance criteria is, and based on that, it's going to create some structural data that can be fed to the next agent. So the output of these two agents is fed to our synthesis agent, which is kind of an integration agent to combine your Figma with the user story to make sense out of it, and then pass that particular unified output to your coding agent, which will actually spit the code which you see over here. Excuse me. So so let's start by looking at the design agent. Now, if you look at the design agent, you would see that, hey, I'm not doing any LLM calls on the design agent. The reason for that is there are some places where LLMs shine, and in some places you want very deterministic 100% accuracy output, and that's where here I'm actually not using LLM and I'm parsing the Figma data structure to get like 100% accurate tree as well as the layout around it. So this is a manual step, right? So there's a lot of cooking that happens behind the scenes to make sure that the code that you see at the end of the day is mostly accurate, right? So it's not like LLM is doing like super crazy magic things and on these types of very structural uh, data. When it comes to the data in Jira. This is the really good case for us to use LLMs, because you can write anything in acceptance criteria, and then there's no way you can actually parse that in a traditional structural programming to make sense out of it, right? And that's where the design agent comes in picture, where sorry, that's where the story agent comes in picture, where you have the the LLM call. So I'm using LangChain, where if you go in here, it is just a call to an OpenAI with an OpenAI key, and it does the magic behind the scenes to return the response. So going back over here, I got the object. This is my custom prompt that I'm letting the LLM know that this is the user behavior story for a Jira story, and this is how I want to handle the events and blah blah blah. And then I'm invoking this particular prompt on the LLM, which returns me this result. I'm parsing that result and returning the page and the behavior back on this particular story, right? So I'm returning the story as well as returning the design, and then I'm passing that to the synthesis agent, which is an integration agent for both of that. Now, if I open this one, this also needs to be very deterministic, right? Because I cannot afford LLM to hallucinate, because since developers are very precise on what they are looking for, if the output result is not accurate in terms of how the structure is and whatnot, and if doesn't run at the first place, they are not going to like it and they are not going to use it, right? So this is still like a lot of deterministic structural programming, I would say, and then you're returning the page, the imports, and the tree structure for your entire design. And then you have your code agent, right? So your code agent is going to again, has its own prompt that, hey, I want to build a React 18 functional component and with TypeScript, right? And I want to use this component UI, which is my own organizational specific component library. And based on that, you also include the imports as well as return code only, and do not actually send me the JSON back, right? So I'm just giving another prompt over here to just let the LLM know that, hey, I'm looking for a code and not any other format. And you can change that, right? This is a very basic example, but yeah, you can make this prompt more efficient based on your use case. And then I'm invoking the LLM again. I get the response, and then I'm dumping that particular response in this particular file, right? So I'm just going to delete this particular output right now, just so that I can run it locally. And it is going to take a bit of time because it's making an LLM API call to the LLM. Yeah, and it gave me a very accurate response every time. No matter how many times I run this, it's going to give me an accurate response. So so what I'm trying to conclude over here is, when you're trying to build a multi-agent system, there are a lot of things on the engineering side that you have to do to to make things work end to end, right? So this was a quick demo on how you can actually include your organizational components inside your multi-agent workflows. Thank you.